Hello again. I'm going to echo John and say this is the last time you have to hear from me today. So erosion is one thing we have to consider early on in the rotation around sustainability. Another thing we have to consider is water, both quantity and quality. So one common misconception about radiata is that it uses all of the water available to it wherever you plant it. And of course, we know that this is incorrect. So what we can see on these maps up here is radiata water use expressed as surplus rainfall, so what's left over from radiata. And you can see it's quite variable across the country, but the take-home message here is really to be found in the South Island in the Canterbury region. So there you can see that although you have some areas where you've got those red dots, which indicates that less than 20% of rainfall is left over in those areas, you also see there's lots of oranges and yellows. And that indicates that even in dry regions, there are still areas where surplus rainfall is between 20 to 40%. So trees can be planted in dry areas. But if water is a concern where trees are being planted, one option is to think, what type of tree should I plant here? So what we can see in this graph here is a number of different radiata genotypes and their water use. So we're looking at water used in liters per centimeter squared increment in basal area. And you can see very clearly that some genotypes are more water efficient than others. So these are in fact the same genotypes you saw earlier that are planted at the Southern Kangaroa trial. So we can choose genotypes for their ability to attract beneficial microbes. We can also choose them for their water use efficiency. All right, so we have our trees planted in the right place. We've got the right stock. Forests can actually provide some really fascinating water-related ecosystem services. So take a look at the top two graphs here. Okay? What we're looking here is the difference in two catchments side by side with different land uses, one with radiata forest and the other with pasture. And you're seeing the difference between those two catchments. So anytime you see a positive number, that means a pasture is supplying more water than a forest. Anytime you see negative, your forest is supplying more water than your pasture. So you look at those top two graphs and you think, wow, pastures always provide more water. Isn't that a bad thing? Well, not necessarily. So in those top two graphs, those are including storm flow. And if you think storms, lots of water coming in over a short period of time, you actually want a land use that can help water infiltrate into the soil, because in a storm event, what you want to avoid is a lot of overland flow that might lead to erosion. So now let's take the storms out. Now look at those bottom two graphs. You see quite a different story. So in the winter, you are still seeing that your pasture is providing more water than your forest, but in the summer, when it's dry, see in the winter there's plenty of water around anyways. In the summer when it's dry, that's when forests really show their true potential, because when it's dry, when we need the water, now our forest is actually able to supply more water than our pasture, which is quite a key ecosystem service of some forests. So great, our forests are providing water. Next question, what is the quality of the water they're providing? That's, of course, going to depend on a lot of issues, but one thing it can depend on is fertilizer use. Now, the first thing you have to know when you're talking about fertilizer use in New Zealand planted forests is that we don't use much at the moment. So in 2017, forestry accounted for 0.4% of national fertilizer use. So it is, at the moment, quite small. Nevertheless, if we want to use fertilizer, the next question is, how can we do it best? So we've looked at this in a number of ways at Scion, and this is one of the studies we looked at where we added nitrogen fertilizer to a quite young stand. This is in fact quite close to the Southern Kangaroa Accelerator trial, and you saw earlier that using New Balm, we had identified that in order to reach our target productivity, we had to add 500 kilos of N per hectare. So that's what we did, all at once. And then we looked to see, okay, how do different surface forms affect what happens to the nitrogen? So we looked at mounds, windrows, and interrows. And we asked the question, where does the nitrogen go? And this is the answer. So what you get is initially you add your nitrogen and you get this pulse of ammonium in the soil. This then is slowly converted to nitrate over time. Nitrate, of course, is vulnerable to leaching, so this is what we want to avoid. Now, at this age, we can't really count on the trees to do much. They're taking up 20 to 60 kilos of N per hectare. What we really need is for the nitrogen to stay on site for a while. So how can we facilitate that? Well, what we see looking at our different surface forms is that organic matter plays a huge role. So when you compare the interrow to the windrow in those two graphs, what you see is in the interrow you get that huge pulse, and then essentially you're just slowly losing it over time. Whereas in the windrow you get these smaller pulses over time because that organic matter can hold on to your nutrients. And we also see this then in the leaching. If we compare leaching under interrows as compared to mound and windrows, you see significantly more leaching under interrows than you do in windrows and mounds. So when thinking fertilizer addition, if you can add to areas with organic matter and for young trees close to tree mounds, that can really help to keep nutrients on site. Also, though I don't show any results here, it's really key when thinking about when to add fertilizer to remember that leaching cannot occur without drainage. If there is no drainage, there will be no leaching. So avoiding drainage is also really key to keeping nutrients on site. So this was one study. We looked at where, we looked at a little bit about when. Another study, we looked at how, using experimental methods of fertilizer addition. How should we add fertilizer?